Okay, welcome back to the another session of Pandas. I have started this Jupyter notebook from Anaconda prompt, and I have started it from the directory where my data sets are present. So that I don't have to change the path of the data set. And I have imported the data set. I have imported the packages such as Pandas and NumPy because as I said in as I said in my earlier videos that you need to import the packages every time when you start a new session. So what is the agenda for today? Today we are going to first we'll see how to import the data and then how to subset the data, then some arithmetic operations and mappings, and then we'll talk about some missing values or missing data in the data set and couple of manipulation functions, so such that sorting and ranking and hierarchical indexing. So this is what we are going to do today. So first of all, I'll show you how the NumPy list can be converted to a Pandas series. First one is if you label them as ABCD and the list of 4 numbers. So a NumPy array would look like this, and if you want to show them what are there in this array, you can see that the array has 50, 60, 70, and 46. We just want to print the numbers, and you will get only the list value. And since we know that in NumPy we don't have much options, uh, but the indexings are defined automatically, in Pandas we can customize our indexing. In this case, I am actually using the labels as indexes and these numbers as the values. So we'll create a dictionary with ABCD as index and 50, 60, 70, and 47 as the values. And let's populate it and see how it looks like. Okay, so it looks like this. Now, if we want to look at this series, you can see they have these indexes 0, 1, 2, 3. Okay, and if we want to change by using this ABCD, if you want to change the indexes, the index will get changed by ABCD. Okay, so in the earlier case, the indexes are 0, 1, 2, 3. In this later case, it is ABCD. So in this case, if you want to just populate the list, the indexes are 0, 1, 2, 3 with the numbers, and in this case, the indexes have been changed by the levels. So ABCD, as you can see, ABCD is the indexes for the same. Now, without writing this and this, without writing data equal to or index equal to, we simply have to write the position. We simply have to write the parameters at the defined position. So if you want to see what does it exactly mean, so in the pd.series, data is equal to none, index is equal to none. Okay, so first one is for data and second one is for index. So that is how it works. Now we have array defined over here, which is 50, 60, 70, and 47. If we want to put them in a series, it will look like this with indexing 0, 1, 2, 3. And the same array, if we want to show it with a level index, so as I showed you, the first position is for data. The first position is reserved for data, and the second position is reserved for index. And if we simply use pd.series and simply put the parameters, we'll get the values as ABCD 50, 60, 70, and 47. And another way of defining a series is by dictionary, as I mentioned. So you can define your dictionary over here with the indexes, and you can simply use series function to populate that. So once we see the series, we can generalize the series, or we can have multiple series in one place. So and that is called data frame. So let's define a data frame with the help of series. And here I can, here there is a club where people teach people, there is a club named Club 1 where people teach martial arts, and the number of students or the number of students in respective martial arts are given in this. So if we run this, we'll get the index as the martial art name and data as the number of students. So if we are interested in looking at the number of students that are present in the martial art form Taekwondo, we'll have to run this and we'll see that in Taekwondo there are 11 students. In the same way, instead of giving the name of the index, if we simply put the index number, it will still show the same value. So Taekwondo is actually at the 0 position. So as you know that in Pandas, the number shifts by -1. So it is actually at first position, but it starts with 1 minus 1, and that is how it is called as club 10. So it starts with index 0. Let's define another club with the different martial arts, taekwondo, karate, judo, and jiu-jitsu with different numbers of students. So in this case, 1, 2, 5, 4. And let's run this and find out what all is there in the club 2. Okay, so in taekwondo, there is only 1 student, karate, there are 2 students, judo, there are 5 students, and jiu-jitsu, there are 4 students. Okay, now you may be interested in adding the total number of students who are learning in club 1 and club 2. So if we run that, let's see what happens. Okay, so we got 2 nan and then rest of them are some numbers. So why 2 nans? Because judo is not present in the first club and kung fu is not present in the second club. So you need to have both the values, you need to have both the indexes present in both the data sets. Only then you can, only then we can do some arithmetic operations on this. So no matter, so instead of plus, if we write any other operations, it will still give you nan for judo and kung. But all the indexes which are present in both the uh, clubs, for them, they will simply add the number. Or if we just put multiplication, it will multiply the number. That's how it works. Let us define another data set with indexes x1, x2, x3 till x10 and columns as points 1, points 2, points 3, points 4, and points 5. So basically this data set is going to have 5 different columns and 10 different rows. When we run this and we want to see what all is there in this data set, we can see there are 5 columns, points 1, points 2, points 3, points 4, points 5, and there are 10 different rows in this data set. Okay, so if we are interested in looking at the column points 3, what is the content of points 3, we can simply write df and then column name, which is points 3, and you will get this list of the numbers, this list of numbers. So this middle, so this list will populate if we write df points 3. In the same way, if we are interested in looking at 2 different columns, then we need to just write the name of the columns inside square bracket, and it will give us 2 different column names. Okay, so there may be situations when we have to create another new variables by using some arithmetic operations. So as here we can, as here I am going to show you how to create another variable 0.6 by adding points 2 and points 1. Okay, so when we run this, we will have a new variable called 0.6, which is sum of these 2 variables, points 1 and points 2. Okay, now wherever you see axis equal to 1, the axis equal to 1 means it talks about columns. Okay, so when we write access equal to 1 and we run this, once we created the new variable, the other function is drop. By using drop, so let me first run this. By using drop, you actually drop the column name, and wherever you see access equal to 1, that means you are talking about columns. Okay, and in place is equal to true, that means wherever you see in place is equal to true, it means you are interested in overwriting this data set, not by replacing it. So if by default in place is equal to false, so let me show you by default what it is. By default in place is equal to false. So you need to explicitly mention in place equal to true for keeping the same data set. Otherwise, it will create another copy of TF. So let's run this. Okay, so this points, we will use it by points 4. And as you can see, there is no point 4 and 5, as I have dropped points 5 earlier, and then just now we dropped points 4 as well. So this is how it works. In the case of access equal to 0, wherever you see access equal to 0, it means we are talking about rows. And since we have given the index number x8, so it will drop x8. So it has dropped x8. Okay, so there is no data frame called data frame, it is df. And that is why it was giving some error. Okay, so now as you can see, there is no x8 in this data set, in this data frame. Now, in case you want to see the all contents for a certain index. So suppose you want to see the whole contents for x4 index, then you need to run this by using df.lock x4. So there are two methods called lock and ilock. Whenever you use lock, it gives the content of the whole rows or column, whatever you write. Okay, if you just simply write ilock, in that case, ilock, you need to provide them the index number and then not the index name. Okay. Now, what happens when we have an index as well as a column? So basically, what happens when we have a row name as well as a column name with lock method? And it gives you the intersection of these two, which is x3 is nothing but this, and 0.1 is this. So intersection of this and this gives you minus 1.983 something. So this is how it works. Okay. In the same way, if we want to have intersection of two rows and two columns, we'll get the values which intersects between two rows, between the given rows and given columns. So in this case, it is x2, x3, x2, x3, and points 1 and points 2, points 1 and points 2. So basically, it will give you 0.0080, minus 1.43, minus 1.983, and minus 1.106970. So that's what it gives now. Okay. Then we can also run the conditional selection. So basically, the conditional selection in Pandas is similar to NumPy. Okay, so conditional selection in Pandas is similar to NumPy. We can simply use the data frame with the conditions, and we will get all the logical or Boolean values. Okay, so in case we want to see the data frame where the values are greater than 0.5, you can see like this. So why it is giving NaN? Because you are asking him to give you only those values which is greater than 0.05, and it is clueless about the values which is what he is going to do for the values which is less than 0.5. Okay, so that is why it is none, and are only true values are being populated here. So this is how it works. In the same way, if we want to use conditional selection criteria on a specific column, so like this, in a specific column, okay, so df points 2 is greater than 0.5. So here 0.5 is greater than, so in the column points 2, what are different values which are greater than 0.5. So 0.5, anything which is greater than 0.5 is x5, and then the other one is x10. So those two values should populate here, and that is what it is doing. But we are asking him to give everything which is there in this selection, and that is why it is populating the available columns. Okay, so that is how it works. Now, in the same way, if we are interested in showing up only, so if we are interested in selection, so if we are interested in selecting the criteria from points 1 column and displaying just the values from points 2, so we need to provide it as this. So it should first select the values which are greater than 0.5 from the column points 1, and then it will populate only those values which are corresponding to points 2. So if I want to make it clear, if I want to show you again, it is first go and check with all the values of points 1 column, and in the points 1 column, the values which are greater than 0.5 are x4, x6, and x9. x4, x6, and x9. Okay, so we have x4, x6, and x9, and then it should select the values of points 2. So points 2 is 0.198, x4, x6 is minus 1.118173, and x9 is 0.247238. So that's what it shows. Okay, again, here in the same way, if we are interested in populating two column values based on some conditional probability on a third variable, we have to write it like